I would like to invite other author, Kaguro Yamaguchi, who will present the dynamic measurement of CTOA and its application to numerical model of unstable ductile fracture of high-pressure gas pipelines. Please.
I'm Hikaru Yamaguchi, belong to the University of Tokyo. I would like to talk about dynamic measurement of CTOA of unstable ductile fracture of high-pressure gas pipelines. This is today's outline. First, introduction. Demand for natural gas has been increasing due to less carbon dioxide emission. So demand for larger diameter and high-pressure natural gas pipelines are increasing. This is an example of accidents caused by unstable ductile fracture of gas pipeline occurring in Texas. Unstable ductile fracture is a phenomenon in which flux propagates at high speed at 100 meters per second to 500 meters per second. At present, it is necessary to raise reliability for fracture prevention due to high pressure and large diameter in gas pipelines. I explain the mechanism of unstable ductile fracture. As shown here, unstable ductile fracture is a mutual coupled phenomenon of gas decompression and crack propagation. And if the crack velocity is faster than the gas decompression rate, the crack propagates. About fracture criterion. This slide shows two criteria, local strain fracture criterion and CTOA fracture criterion. First, local strain fracture criterion. This is reliable as ductile fracture criterion, but difficult to measure. Secondly, CTOA criterion. CTOA is crack tip opening angle. This can be measured in DWT, but measurement examples in past tests are very limited. Okay. By the way, DWT is drop weight tear test. And past test is pipe unstable ductile fracture experiment. So, relation between CTOA in DWT and actual pipe unstable ductile fracture is unknown. I will introduce the previous research on CTOA. This is a study of the CTOA in DWT by Wilkowski. There is a part where CTOA is a constant value. But this study does not compare CTOA of DWT with CTOA of bypass test. The following study is a study of CTOA of bypass test by Albert Kobayashi. This is the only CTOA measurement of bypass test we know. They observed a crack velocity dependency of CTOA resistance value. However, the reliability is not high from the point that the number of frames per second of the camera is small. And the experiment method, which is not common. Frame rate was 8,000 frames per second, and they machined a groove on the pipe wall. It was presumed that the CTOA resistance value might change whether the crack propagates along the groove or not. Therefore, we carry out the pipe pass test to validate the CTOA criteria by measuring CTOA in pipe pass test and comparison with CTOA in DWT. Objectives are first, measuring CTOA in DWT. Second, measuring CTOA in pipe pass test. Finally, finite element analysis to validate CTOA criteria. Second, experiment. This is outline of the experiment. The table above is pipe configuration, pipe grade, outer diameter, and pipe thickness. The table below is material properties. Firstly, I'll explain from CTOA measurement experiment in DWT. This is outline. Falling weight is 200 kg. Height is 2.8 meters. The design drawing of the test piece is shown here. We conducted two bodies, number 1 and number 2. This is the result video. High-speed camera setting is shown here. These are the images taken from the high-speed camera video. CTOA was measured from this image. This is the result. CTOA is about 22 degrees. The measurement position is about 2 mm behind the crack chip. The steady state was realized at crack length of about 15 to 32 mm. While this crack velocity changed from 10 meter per sec up to 4 meter per sec. Next, I will explain CTOA measurement experiment in 5 pass test. This is outline. This step shows length, notch depth, gas, and burst pressure. Nitrogen gas was introduced into the pipe, and the pipe was bursted by internal pressure. CTOA was measured by high-speed camera from the direction of the pipe axis. This is the result video. Burst pressure is 16.5 megapascal. High-speed camera skin is shown here. These are the images taken from the high-speed camera video. CTOA was measured from this image. I'll explain the CTOA measurement method. Firstly, points were plotted along the crack edge, 10 mm behind the crack chip. Secondly, approximate the point to two straight lines. And finally, the angle made by the two straight lines was determined as the CTOA value. However, the CTOA value calculated in this way is a value on the observation surface, shown as a blue plane. So, the CTOA value was converted to that observed from the top of the pipe. This is the results. CTOA is about 12 to 18 degrees. The measurement position is about 10 mm behind the crack chip. The CTOA resistance value stayed almost constant at 500 to 1500 mm, in which the crack propagated steadily. The crack velocity decreased from about 200 meter per sec to 100 meter per sec. This CTOA value is smaller than that measured by the DWTT. CTOA in DWTT was 22 degrees. Next, finite elemental analysis. FE analysis was conducted to simulate dynamic crack propagation in the axial direction in a pressurized pipe. Objective is confirm the relationship between local strain criterion and CTOA criterion. We validated the using of CTOA as criterion. This is outline. This video shows an example of pipe wall deformation. Our mesh minimum element size is 0.5 mm. The Rayleigh damping coefficient was also determined from this equation to control the vibration. In addition, each parameter value is shown in this table. Outer diameter, design factor, crack velocity, diameter by thickness, and pipe grade. Design factor is value relating to burst pressure. By changing each value, it was confirmed whether each parameter has dependency in the relation between strain and CTOA. I'll introduce some of the results. These shown here are graphs of influence of crack velocity and strength. The horizontal axis shows the equivalent plastic strain, and the vertical axis shows the CTOA in 2 mm behind the crack chip. From these results, it was confirmed that there was real dependence on crack velocity and strength. The same result was obtained for D by H and design factor. On the other hand, the dependence was confirmed for the outer diameter. Therefore, CTOA estimation formula with outer diameter and equivalent plastic strain as a variable was determined by fitting. From the above results, the CTOA resistance in the pipe burst test can be estimated. I will explain method of using CTOA estimation formula. Firstly, we can measure CTOA sheet in DWTT by high-speed camera. Secondly, we need to determine efficient PCD in DWTT by finite element analysis. This is future prospect. Thirdly, we can determine CTOA sheet in bypass test by this formula. Finally, conclusions. First, it was confirmed that CTOA sheet takes a constant value without velocity dependency for both DWTT and bypass test. But these values are different. Secondly, local strain CTOA relation was established from FEM. Finally, we proposed an estimation formula to find the CTOA sheet in bypass test. And future prospect is that conduct finite element analysis in DWTT and compare CTOA with FEM in bypass test. Thank you for your attention.
Thank you, author, for very interesting lecture.